how you distribute loads when you've got eccentric loads within a group of bolts. So it's quite nice and simple when you've got a concentrically applied load, so applied through its centroid, and the load in each bolt is simply the full load divided by the number of bolts. So all bolts are carrying the same load. Now, if you increase the eccentricity, you're inducing a moment, and so therefore the load in the bolts increases as a proportion of the distance from the centroid. We can break that into two components, the concentric load and the eccentric load causing the moment. So let's look first at the concentric load, and as I've mentioned, you just take the full load and divide it by n, the number of bolts, to give you the reaction in the bolt. And so for equilibrium, the sum of the horizontal and vertical forces should balance out. Now look at the moment arising from the eccentric load, and the load in each bolt is proportionate to the distance from the centroid of the bolt group, and the resulting force is the moment applied multiplied by the distance from the centroid divided by the polar moment of inertia of the bolt group. Now the polar moment of inertia of the bolt group is simply the sum of the distances of the bolts squared from the centroid. That can be broken down into an x and y direction, so you can have an Rx and an Ry. We do that so we can combine it with the load we derived in the concentric load. Okay, nice and simple. So you're deriving something simple from something that's quite complicated. But what you normally do is you design for the worst load case.